Franck, we hope to listen about container story as about the previous steps and about our future. And please.
Okay. Good morning and welcome to everyone to this session. So my name is Franck Descollonges. I'm working in IBM since more than 20 years now. And I'm a cloud developer advocate for extended Europe. So I used to come in Moscow and in Russia previously to talk about containers, clouds, and hybrid clouds. But today, I don't really want to have a deep technical talk about clouds and its underlying technologies, but I want to tell you a story. In fact, I want to tell you a story, or maybe it's not a story, it's a journey. It's a journey we are currently living when we are talking about clouds, and it's a journey towards multi-cloud. So maybe this title of this session should have been A Journey to Multi-Cloud. And you will see that in this journey, containers and containers technology has a great importance. So I hope you will enjoy it. And anyway, if you have any question, please feel free to ask. So to start, I'd like to quickly start with the basics, the IT stacks. When you want to deploy and to run an application, you have a set of requirements. First of all, you need some hardware. Hardware pieces, such as CPU power, such as storage to store data, networking to make the communication all together. On top of that, you will need to have an operating system to make this working correctly. If you need to optimize the usage of your hardware, you will probably need to have some virtualization on top of that operating system. Next, as an application developer, you will need to rely on some SDK, some application server, some languages, some middleware that you will use to build your own application. And on top of that, you will have the data. The data is the core of your application. This is basically what we call the value for the customer, for the application. So that's really a key part. And then you have the application and the applications code. So I'm 100% sure that all of you knows about these IT stacks. There is nothing new, but this will be basically the red line I will follow through that journey to multi-cloud. So as you imagine, for every single piece of that stack, you need to have some specific skills. And in a company which is not an IT company, it might be difficult to have all that skills at the right level every time. So in the past, some companies that are not IT companies decided to externalize all the IT stack into external companies. It started with some simple applications such as mail, customer relationship management, office tools, and everything was managed outside of the company, not internally. So this is what we have called software as a service. It started in years 2000, and it's still available, and it's still a valid model. But as the application needs to be customized or tailored to specific needs, it might not fulfill all the requirements of all the companies. So some people decided that instead of externalizing all the application, maybe they only have to externalize something that is really complex, which is everything about the hardware and the virtualization. So this is what we call infrastructure as a service. So that means that we are delegating all the infrastructure parts of the IT stack to someone else who is an expert in that domain. So that's great, but there is still a lot of pieces in my stack to manage, and these stacks are quite complex as well. So instead of building all the operating system, runtime, and middleware, as an application developer, I usually want only to focus on two things, the data and the code. I don't want to worry about how to install an application server, how to configure an SDK, how to select a language, how to create a virtual machine to run my application. So we have a shift from software as a service to platform as a service, meaning that for a developer, for an operator, it could be really useful to have a set of predefined environments based on your need, based on your favorite language, based on your favorite application server, ready to be used in a few minutes for you just to create your code and deploy that code to that platform. This is what we have called platform as a service. And an example of platform as a service is Cloud Foundry. You have probably heard about it. So, this is something very important. But what happened in the IT industry is a kind of big shift. I wouldn't say a revolution, but it's really a big evolution and a big focus. And it's the same kind of evolution that has happened in the transport industry when someone, once in time, was thinking about, instead of shipping product in a bulk way on ships, maybe it would be useful to put all the product inside a standardized box, and this box could be put from one ship to another ship, from one ship to a train, from one train to a truck, and so on. And in the IT industry, the idea has raised and has been has taken a high importance, especially with open source version of containers with Apache starting in 2013. So really, the idea is to put everything that is related to an application inside a box, so that box can be used in any part in our environment. So, why containers are so important? Why does it work? The main thing is about separation of concerns. Depending on your role, you will not have the same concerns, but you can use containers anyway. For instance, if you are a developer, you have to focus on your code. You have to focus on the libraries that are required by the code. You need to focus on how to manage the dependency between the libraries and the code with the package manager, data, app. This is everything that a developer has to focus on. And from a developer point of view, wherever you are deploying your application, you really don't mind. You just need to know and to focus on your language and on your application code. On the other hand, you have the guy who needs to deploy that application, to put that application onto the piece of hardware, the piece of virtual server on which the application has to run. And he's not really focusing on what is the application doing. He's focusing how to make that application run and check that application is running fine. So it has to look at every log that is generated by the application. It has to look at the monitoring, what is the status of this application, and the configuration, the communication between this application with other applications, and so on. And from this point of view, with containers, everything that is inside the container is hidden. And all the containers look the same. So it can work with an application running in Node.js or running in Python or in Java. From the outside, it does not have to know anything about it. So that's really key, that with containers and containerization of application, we can be more productive. So this is the main advantages of containers. First advantage is application portability. As container can be isolated, they can run on any environment. They have not a strict adherence to the underlying layers of the IT stacks. So that means that you can move your container from one environment to another environment. And that solves a second issue, which is it prevents this typical sentence, it worked on my environment, but it does not work in the next environment. For instance, it was working in development, it's not working in test. It was working in test, it's not working in production. With containers, the idea is to avoid this kind of problem. Being able to have one single package with all the dependency, all the structures that are required to take as a whole, as a block, your application from one environment to another environment. So that means with reducing this risk, you can ship more software, so you can be more agile, have more reaction to the market, and so on. And last but not least, container is lightweight, is really resource efficient, because it will be able to reuse parts of all other containers that are running on the platform. So it is it has a very good usage of all the underlying infrastructure that is available for all your applications, because you don't have only one application to run on one single computer, for instance. So this is a technical view of what is a container. So a container is based on layers. And as you can see here, you can reuse a set of layers. I will not get into the details, but what you have to remind from this slide is that once you have a container that is requesting a layer, if this layer already exists in the container environment, then it will be able to reuse it and not reload it, not using more memory for using that layer. So that's great. We have containers. We have our application running in one container. But the question is, what do I do when I have 10 containers? What do I do how do I do when I have hundreds or thousands of containers in my infrastructure? Because you might want to have microservices, and each microservice might run inside of one single container. So you will have to manage communication between all the containers and so on, availability. So why do you need container orchestration, and what does that mean? If you have one single container, it's like having your pets, your own personal pets. You can take care of it. You can give him a name. You can check if he's feeling well. If he's sick or if he's dying, you are sad. So that's something difficult for you. But if you have hundreds of animals, like a cattle, you will not have the same relationship with each of them. You cannot check everything. So that's the same analogy for containers. If you have one container, you can really, I would say, take care of it and check its availability, its health, monitoring, and so on. But if you have hundreds of containers, you need to work with container as a whole, as a bunch of containers. So you can apply label to choose which container you want to take care of. You need to focus or to replace one container by another container. With your own personal pet, you will not do that, so it will be heartbreaking. So, container orchestration is key. What does that mean, container orchestration? It means how do I manage all my container across all the physical resources that are available in my infrastructure. And here comes the most famous container orchestrator tool, which is called Kubernetes. And this is the definition of Kubernetes. Kubernetes is an open source platform for automating deployment, scaling, and management of containerized application across cluster of nodes. So, first key point, it's an open source project. So this is very important. It has been created by Google, but Google has given Kubernetes to the open source community. So it's now 100% open source, and it is managed by the Cloud Native Computing Foundation. It runs across a cluster of nodes. It means that your containers and your containerized application will be deployed amongst multiple physical servers or virtual machines. And Kubernetes is made to help the deployment of this container across all these clusters. Let's have a look at the architecture of Kubernetes. So Kubernetes is based on basically two kinds of nodes. This is a simplified architecture. Two kinds of nodes. The first node is about master, for management of the cluster. And the other kind of nodes are worker nodes. Basically, worker nodes is a place where your application will actually run. This is a place where you will have to scale, where you will need to increase the load, for instance. So master node can be highly available. You can have multiple master nodes. Worker nodes, of course, will be multiple to handle all the workload of all your application. And just to give you some information about what you get in the master nodes. In the master node, you have the API server on which you will be connected, on which you will, with the API, you will control the cluster. You will have a scheduler. What is a scheduler? The scheduler is the place that will, it's a part that will control where you will place your container. For instance, if you want to deploy a new container, on which worker node will you deploy this container based on your constraints, based on labels that you can have on your containers and so on. And you have the controller manager. The controller manager is a key piece for Kubernetes, because in Kubernetes, you are working in a declarative approach. You tell to Kubernetes, I want to have this application running, and I want this application to be running in a highly available manner. For instance, I want to have 3 instances of my application. You say that to Kubernetes, and Kubernetes, with the controller manager, will ensure that every time you will have 3 instances of your containers running in all the worker nodes. So, what are the capabilities? First, intelligent scheduling. Scheduling means placement of container. So when you have a new container to be deployed or restarted, Kubernetes will take care to deploy that container in one of the worker nodes that is available. Self-healing, meaning that if one container is failing or if one node is failing, it will try to restart the container. It will try to restart all the containers that are running in one node. So that the declaration you have made is still valid. Horizontal scaling is making the container, the application able to handle more requests. So you can multiply the number of instances of each container amongst all the nodes available. We have 100, maybe more services. So all these services, all these containers must talk to each other. As Kubernetes is managing the placement of all the containers, you never know on which physical node or virtual machine a container will be deployed. So you need to find a way to make one container talking to another container. Kubernetes will do that using DNS mechanism or all kind of stuff. It will help to manage upgrade and downgrade of your application, because you can upgrade one container, meanwhile the old container is still running, and then stop the oldest version when you have a new version available. So you can make your rollout of new version more easy. And last but not least, you will be able to manage everything that is related to the configuration of your container. When your application is running in test environment or in production environment, they don't have the same environment. For instance, they are not using the same URL for the database. They are not using the same user ID and password for accessing the database for test or for production. So everything can be managed outside of the container based on secret and configuration management. So Kubernetes is really great for managing all the containers amongst all your nodes. But it's not sufficient. It's not sufficient if you want to have a fully production environment. So, of course, you will have container orchestration with Kubernetes, but beneath that, you need the infrastructure. We have seen that. And probably some infrastructure as code to help you to manage your infrastructure more easily. You will have image registry to store all your images for being used by the container orchestrator. You will need to package your images all together. An application is not one single container. It might be a set of multiple containers, one front-end, one back-end, one database, for instance, and with a set of tools, a language. You will have to manage logging, monitoring, and, of course, DevOps to ensure continuous delivery, continuous integration, and so on. And probably, if you are doing microservice, you will need some tools for service mesh. So now, it's a matter of choice. Which project are you using for all that pieces? For instance, for monitoring, you can use Prometheus. For logging, you can use Grafana. For service mesh, you can use Istio. But this is only one choice amongst hundreds of projects that are existing and this is just a chart from the CNCF company that shows all the ecosystem around Kubernetes, about Cloud Foundry, about containers, and so on. So, really, just to give you an idea, if you want to have a full Kubernetes environment for production, you will need at least 50 components that are working together. And all that components have their own life cycle. They have their own versions. They have their own failure, dependency, and so on. So if you change and you upgrade one of these versions, you have to make sure that it does not break all the other components that are running on that. So the question you might think is, do you want to build it by yourself? Bring all these 50, choose one by one, all the components that are required to do that? Yes, you can. But it will be very time consuming and for managing, maybe not for deploying, because the first deployment will be okay, but for the next one, and for the evolution, and for the support, and so on, then it will be really, really time consuming with time. So, back to our red line. And so, basically, cloud provider thinks that, okay, we have this container that is raising, so we can provide container as a service. And it started really simply by providing image registry on the cloud to run containers, containerized application in the cloud. But it was better, probably not to have container as a service, but more Kubernetes as a service. Kubernetes is really the orchestrator for container that has won the market. So now we have Kubernetes as a service, CaaS. And of course, as IBM, a little bit of shameless auto-promotion, we have a managed Kubernetes solution in IBM. And this managed, what does that mean? That means that we, as IBM, in our public cloud, we are managing everything that is related to the master configuration, all the APIs, scheduling, and so on for Kubernetes. We are managing all the infrastructure that is running beneath. If you need to have servers, bare metal server, virtual server metal to run your containers, we will do that. You will only manage the containers that you want to deploy on this Kubernetes environment. This is certified, this is secured, this is highly available. We can have multiple cross-region clusters. So if one data center in one region is failing, we will have higher availability in another data center, for instance. So that's really important. And you can try it for free on the cloud.ibm.com. But we said container can be run anywhere. So why could I not run my container inside my infrastructure? And we are discovering that we can then have the same kind of capabilities from the public cloud into our own infrastructure. So let's call it private cloud. But on private cloud, how do you set up this environment? And I want to introduce you the Red Hat OpenShift. And you might wonder why IBM is presenting Red Hat. Maybe someone has a guess. So IBM recently acquires Red Hat in August of this year. So now Red Hat OpenShift is the official Kubernetes distribution for IBM that you can install anywhere. Oops, sorry. You can install it on a physical device or on a virtual device, but you can install it on a private cloud or in a public cloud. So if you already have some infrastructure managed by VMware or OpenStack, you can install OpenShift. If you have infrastructure as a service with cloud provider, you can install OpenShift. And even in some specific cloud provider, we also have managed version of OpenShift. That's the case for IBM Cloud, and that's the case as well for Microsoft Azure. So you can have OpenShift everywhere. So that's great, because what does that mean? That means that if you have an application that is running in any of these clouds, it can be moved to another cloud. So you can manage your application equally in all the clouds. So we have multiple versions of Kubernetes on multiple clouds. This is a few of them. If you are going to CNCF dashboard, you will see hundreds of Kubernetes engine. So why should I use and why should I choose only one? And that leads us to the multiple clouds and the multi-cloud. So why could not we choose the best of the breeds depending on our needs? And first reason to have multi-cloud adoption is to have an hybrid cloud. There is some data and some workload that cannot go outside of the private space of the enterprise. So we need to keep that in the private space. But there is some services, AI services, big data services that are only available in public cloud. So having an hybrid cloud with public and private is great. And having the same infrastructure to manage our application in public and private is great. But that's not the only reason to manage multiple clouds or multiple clusters. We can have cluster spanning across location. If you have some customer in the eastern part of the country and some other customer in the western part of the country, you might not want to have the latency of the network to cross all the country each time you are making a request. So why not have a part of your cluster in the eastern part and one part of the cluster in the western parts? And you can also have cluster spanning based on the purpose for production, for test, for development. But having multiple clusters is raising new challenges because you need to have a greater view amongst all that cluster. You need to have governance and you have application management. And that leads us to something that would be great to have, is to have, for instance, for all the cluster, whatever the data center, whatever the cloud provider, whatever the kind of Kubernetes distribution we are using, we'd like to have a view on all that cluster, checking in one page what is the health, the usage of all that cluster. For instance, on that screenshot, we will see that we have a list of clusters running on Azure, on Google, on IBM, public cloud, in the local data center, various kind of clusters. The usage for all that cluster on the bottom, the type of usage, the number of applications that has been deployed. One single view, 300 degrees view of all the information for your clusters. But each cluster will not have the same purpose. Some cluster will be for, we need to comply to some security policy. For instance, a production cluster does not have the same security constraints as a development cluster. So you need to be able to manage policies and rules to help you to control what will be deployed to what cluster. For instance, if you have to follow some security rules to deploy your application, then you need to enforce that rules. And you will be able to create security policy and check that this security policy are correctly enforced. And last is about application management. When you deploy your application, because you have to deploy that application, that's the final goal of these clusters. You need to be sure to deploy it in the right cluster. You need to be sure to be able to monitor this application wherever it has been deployed. You need to have a consolidated view of that application on all the cluster, on all the dependency. And that's really, really key. So, before finishing, let me introduce you the IBM solution for multi-cloud management, which is called IBM Cloud Pak for multi-cloud management. The screenshot you have seen before is just a little part of this solution. It is called IBM Multi-Cloud Manager, which is a product which is running on top of OpenShift that can run in your data center, or it can run in the cloud, as it can run in any OpenShift distribution. And what we have seen so far as a slide is application management, multi-cluster management, and security and compliance management. But managing managing application and managing multiple cloud is more than that. It's also managing the infrastructure. It's also managing all the events from all the data center and all the customer. It's also managing the virtual machines, because everything is not containerized yet, so you still have to manage some virtual machines. So IBM Cloud Pak for multi-cloud management, I would say it's another story, and I will be more than happy to present it to you in another session, or to come back to St. Petersburg to make a session with you. So I'd like to thank you, and if you have any questions.
Thank you very much, Frank. And any question? No question? Okay. Франк какое-то время тогда будет стоять у входа в зал. Если кто-то захочет пообщаться с вопросами персональными, пожалуйста, обращайтесь. Frank, thank you very much.